All right, guys, we're going to go on and get started with the lesson here. No.
Yeah, I was talking to Hopper and then I had to go pee, so I just figured I might ought to go pee before I come to class.
So the first thing we're looking at is tangent and intercepted chord theorem. Now, whenever we have a tangent line, the angle that the tangent line and the chord make is going to be half the measure of its arc. So here the measure of angle 2 is going to be half the measure of the chord ACB. Or angle 1 is half the measure of chord AB. So whenever we have a tangent in a chord, it's half the measure of its arc. So if we look at the first one here, so we have angle 1 and the arc that composes it. So the measure of angle 1, 1/2. Measure of angle 1 is going to be half the measure of its chord. And what's the measure of the chord for this one here? Yes, but it's in a little bit different setup because what we talked about yesterday was intercepted angles to where the vertex was on the circle. So it's a little bit different setup, but the formula is the same. So here we're taking half of 130 or dividing 130 by 2, which gives us what? So here the measure of angle 1 is 65 degrees. Any questions on this here? Are you ready for the next one? Now on this one here, we want to find the measure of arc LJK. Well, according to our theorem, the angle L is equal to half the measure of the arc. So we're saying that the measure of angle L is equal to half the measure of the arc LJK. But what are we told? We're told what the measure of angle L is, which is 125 degrees is equal to half the measure of arc LJK. Well, LJK, arc, this one here. But to get this by itself, we have to multiply both sides by 2. So the measure of the arc, LJK, is just 2 times 125, which is 250. Yes. They end up throwing those at the beginning of some of the games.
Catfish?
Yeah.
Like live ones?
No. So with this here, if we're given the angle, we can multiply it by 2 to get to the arc.
How would they be inside catfish?
No. Possibly. So if we're given the angle, we can multiply it by 2 to get to the arc. Or if we're given the arc, we can divide it by 2 to get back to the angle. So any questions on this here? So this one here, are we given the arc or the angle? Arc. So to get back to the angle, we need to do what? We can take 240 and divide it by 2. So here the measure of angle 1 is that's it. Are we ready for the next one? Okay. Because the measure of our angle that's formed by the tangent in a chord is equal to half the measure of its arc. Or going the other way around, the measure of the arc is equal to twice the angle. Now for this one here, we're given the angle, and the measure of the arc is equal to twice the measure of the angle formed by the tangent line and a chord. Well, here we want to know the measure of arc LJK is equal to 2 times the angle. And our angle is what? Which, yes, angle L, which would be 155 degrees. So we just need to multiply 155 degrees by 2, which is, yes, 310 degrees. Which is expected because if we look at the arc is almost a full circle, and a full circle is what? 360. Questions on this here? We ready for the next one? Okay. What would LK be? Because this little arc down here would be, because the whole thing is 360. So how would we find the measure of angle 1?
210 divided by 2.
Because the angle is half the measure of its arc. So we would take 210 degrees to measure the arc and divide it by 2 and get 105. 105 degrees. Questions on this here? I believe this is the last one of this type. We're going to find the measure of arc RST. What do we need to do? What by 2? And if we multiply 98 by 2, we get what? 196. Because 8 would turn into 16. So we would carry that 1. Questions on this here? We ready for the next thing? Let's look at the next core concept. Now, if we have 2 lines, 2 secant lines that intersect a circle, there's 3 ways that the lines are going to intersect, guys. There's 3 ways that the lines are going to intersect. One is that the 2 lines will intersect on the circle. One way that 2 secant lines will intersect on a circle is on the circle. The next way is inside the circle, and the last way is outside the circle. So if we draw 2 lines intersecting into a circle, the 2 lines will intersect each other either on the circle, inside, or outside. Only 3 ways we can draw these and have them intersect. Now, if the 2 lines intersect inside the circle, here, angle 1 of these angles, is going to equal the sum of its 2 arcs. 1/2 of the sum of the 2 arcs. So if we take arc DC and AB, add their measures together and divide it by 2, we get the measure of angle 1. Well, we actually also get this angle too, because they're vertical angles and their measures are going to be the same. We can say the same thing about angle 2 and these 2 here. The other way that can work is if the angle or the 2 lines intersect outside the circle. If they intersect outside the circle, the angle that is formed here, here, or here is equal to half the measure of the bigger arc minus the smaller. Half of the bigger arc minus the smaller. Any questions on either of these theorems? So when we look at this first theorem, or this first example, do the 2 lines intersect inside or outside of the circle? Inside. So our angle is going to equal 1/2 of the arc plus the arc. Is the formula that we're going to use. Now our angle here we have is plus yeah. So if we solve this here, we can do 156 plus 130, which is 286. And if we multiply it by 1/2 or divide it by 2, we get 143. And that's it. Now with this formula here, x, our angle, and the two arcs are really going to line up.
We're not going to do the arc of L.
No, we're not too concerned with it because we really just wanted the value of x. I mean, we could find it based off the fact that these two here do add up to be 180 degrees and can go from there, but it's not too big of a concern at this point.
Question.
Yes.
If you go to find the angle, so like what we did last, like right here, so we have to divide it by 2. Well, if you do 156 divided by 2, you don't get it.
Because it's not necessarily a central angle or a inscribed angle. Because inscribed angle, so if the angle was on the circle, then we could do that. If it was a central angle, then it would match it. So that's just telling us that this point here is not a central angle and it's not on the circle. So those two formulas don't necessarily work. Any other questions? Let's look at the next one. So is the angle here that is formed by these two lines inside or outside the circle? Outside. So our angle here is going to equal 1/2 of the bigger arc minus the smaller arc. So here the angle that the two lines make is being called what? Is equal to 1/2 of 78 minus. Now we just need to solve. 178 minus 76 is going to be 102. And if we multiply 102 by 1/2 or divide 102 by 2, we get so the angle C is 51 degrees. Questions on any of this here? Any questions on anything we've done so far? 1/2 of 102? Or we're dividing 102 by 2? Because multiplying by 1/2 or dividing by 2 will get us to the same spot.
So you subtract the 2 from each other, and then you divide that 2, and then you get your answer.
Yeah.
Fair.
Let's look at this one here. So do the two lines intersect inside or outside of the circle?
Inside.
So this one here, we're going based off our angle is equal to 1/2 of our arc plus our arc measure. Well, one of the arc measures that we want to find is, and the one across from it is 80, because when we do the arcs, they do have to be across from each other. Now, do we have the angle for this one here?
94.
Almost, because the angle we need for this is either this one here or this one here. It's 80 what? What do we know about two angles that make a straight line? They equal 180, yes? I know that this is 94, and either this angle here or this angle here should add together to
So
be.
that was going to be 86.
Yes. So to find that, we could take 180 and minus 94, which exactly would give us.
86.
So this angle here is 86, or we could say this angle here is.
And then the one together would come
Now we can solve. So what can we do first in solving? Because we need to get the x by itself, yes?
Subtract x from both sides.
Well, x is being stuck with this 1/2.
Wow.
So what we can do is we can multiply both sides by 2. What's 2 times 1/2? 1. So these here cancel out, leaving us with x plus, well, let's back up. So what is 2 times 1/2? So we have 1 times,
Oh,
yeah, so 1 times x is x, and 1 times 80 is 80. Because we don't normally write it out because the multiplication of 1 is understood at this point. Now the other side, we're going to do 2 times 86, which is?
170.
Last but not least. Yes. And that's it. So really, anytime we have the variable inside the parentheses, we can multiply both sides by 2 and solve. Questions on this here? Any questions on anything we've done so far? Let's look at this one here. Is the angle inside or outside? Outside. So we have our angle is equal to 1/2 of the bigger arc minus the smaller. Now what's our angle this time? Because our angle that we're talking about here is where the two lines intersect, or the angle that the two lines form, which is 35, is equal to 1/2. Which angle, or which arc is the bigger arc? 100. The bigger arc is always going to be farther away from the angle. So 100 is going to be the bigger. The smaller is x. So 35 is equal to 1/2 of 100 minus x. What can we do first? We can't subtract the 100 from 35 yet because the 1/2 is locking it in. Yeah, we have to multiply both sides by 2. Yes. So we're going to have to multiply both sides by 2 because 2 times 1/2 would be 1, which will simplify the right-hand side to just be 100 minus x, guys. 2 times 35 is? What do we need to do next? And if we subtract 100 from both sides, we get that negative x is equal to? Are we finished? No. We need to divide by -1, or we can multiply by -1. But if I know that negative x is equal to negative 30, x is equal to 30. Because if I'm flipping the sign on one side, I'm going to have to flip the sign on the other. Any questions on this here?
Outside. So that's inside. All right. Well, technically the number is outside.
So here we're dealing with the formula, angle is equal to 1/2 of the arc plus the arc. Now we do know what the two arcs that we're looking for, so we'd have 1/2 of y plus but they didn't quite, guys, they didn't quite give us the correct arc. They only gave us 102, the other one. So to find the correct arc, what do we need to do with 102? We need to subtract it from 180. And if we subtract 102 from 180, we get 78. Bless you. Bless you. What do we need to do next in solving for this here? Guys, we need to multiply both sides by 2 to solve this here, guys. These here are going to cancel. 2 times 78 is going to be equal to y plus 95. And last but not least, we need to which tells us that y is y 61 degrees. Any other questions on any of this here? We're going to move on to the last type. The last type of problems that we're going to look at today. And what we have here is a circumscribed angle. A circumscribed angle is an angle whose sides are tangent to a circle. And it works out that the circumscribed angle theorem states that the angle outside and the central angle are going to add together to be 180. These two angles here are going to add together to be 180 degrees. Or we can say that the exterior angle is equal to 180 degrees minus the central angle. So if we look at this here, this is a circumscribed angle, so we know these two angles add up to be yes. Because the central angle and that are going to add together to be 180. And it also works out that the arc AB here is going to be 135 because it's the same as the central angle. Any questions on this here? Now, if we look at this one here, is this angle here a central angle? No. So 30 and it will not add together to be 180. But if we make this one here, this would be a central angle, yes? Now, it and 130 will add together to be 180. And if we subtract 30 from 180, we get 150. Well, the measure of this arc is actually also going to be
150.
because, again, the arc and its central angles will have the same degree measure. And the reason that this is helpful and the reason that we're looking at this here is because this angle, this inscribed angle, is half the measure of its arc. So it's half of
150, so it is.
So for these here, we just had to find the measure of the arc first, so then we can find the inscribed angle. Any questions on this here? So what do we need to do to find the value of x?
Divide or subtract that from 180.
So we do a 180 minus. Questions on this here? What do we need to do to solve for x here?
Subtract 42 from 180,
Okay.
which is 168, 158.
140, 138.
What?
So what's 138 degrees?
And that would be your A to B angle. Yeah, that thing.
So it would also be AOB, yes.
Yeah. So then you.
Then what would we do?
Divided by 2.
Mm-hmm.
That's what I was thinking. You could write it kind of like so 130 divided by 2.
Biscuit for a biscuit.
And the reason that it's half that angle is because that is an inscribed angle. An inscribed angle is equal to half the measure of its arc. Any questions on these here? So this here, what would the value of x? Because we're doing 120 subtracted from 180. Any other questions on any of these here? If we're good with all these here, your homework is on page 510, problems 3, 5, 7 through 14.